Okay, Chapter 27, Powder Drug Preparation. So after reading through Chapter 27, and please make sure you read through it and do some practice problems, the student should be able to explain why some parenteral medications are available in powder form. There's two sources where a technician could find how much diluent is needed for reconstituting a parenteral drug. Calculate powder volume, diluent, and final volume. Calculate the concentration of drug for reconstituting medications. Calculate the volume of reconstituting medications needed to deliver a specific dose of medication. So some parenteral products have limited stability when in a solution, such as antibiotics. So what happens is the drug manufacturers are going to supply those drugs to the pharmacy in a powder form. So when a powdered drug is to be administered to the patient or is added to an infusion bag, it is reconstituted with a recommended diluent. The recommended diluent is usually sterile water for injection. So the antibiotic manufacturer's package insert includes other examples of recommended diluent. So it'll tell you usually on the package insert or on the vial label, it'll tell you how much diluent to add for the reconstitution. So the label on the vial also indicates the amount of powdered drug contained in the vial. So for a couple of them I put the question on here, but then the other ones I'm just going to read. Okay, so I figured the first couple we just do this. So if 95 milliliters of store water for injection is added, so we're going to save this for the end. Okay, we'll save that. To a 10-gram bulk powder drug pharmacy container, the concentration obtained is 100 milligrams per milliliter, so we know that's what we have in stock. 10 grams is what we want. Okay, what is the powder volume of the drug? Okay, so just as a reminder, your water and your powder volume are going to equal your final volume. Okay, so now what we're trying to find is the powder volume. So you have, or you have on stock 100 milligrams per 1 milliliter. We're going to do a ratio proportion first to find our total or final volume. Okay. Then you have your 10 grams of the bulk powdered drug pharmacy container. Okay, so then we're going to try to find X. Powder volume always comes in milliliters. Okay, so it would be X milliliters. So again, we double, just like before, we double check our units. We have weight, both weights on the top, but we have grams and we have milligrams. So we need to change, the easiest one for me to change would be the grams to milligrams because you can multiply it by 1,000, and so it would be 10,000 milligrams. Okay. And we have liquids on the bottom. Both liquids are milliliters, so they match. So then we're going to cross multiply. 10,000 times 1 goes on top. 100 times x, x always goes on the bottom. X. Okay, so we have 2 zeros here. If you want to shorthand this out, 2 zeros here. And we don't have to put in the calculator. So it'd be 100 divided by 1 would be 100. So milliliters. So our final volume is 100 milliliters. It tells us up here we are to add 95 milliliters. So to find the volume, so this is your final volume, and we know that our water is 95, so we need to know the powder volume. So we're just going to subtract it. Okay, so then our powder volume will be 5 milliliters. Okay, now we'll skip down to number 3. The package insert directions for a medication instruct you to add. We're going to save that for later. 4.2 milliliters of sterile water for injection. We're going to a 1 gram of dry powder. So that's what we're wanting. The concentration is what we have in stock is 200 per milligrams per 1 milliliter. What is the powder volume? Okay. So first we got to find our final volume. So we know we have 200 per 1, and we have 1 gram up here because we're going to take it out of the 1 gram. And we'll have X milliliters because we're trying to find powder volume. Powder volume always will have the milliliter symbol. Then we're going to cross multiply. 1 times 1, it goes on top. Oh, wait a minute. I get ready to make a boo-boo. Okay, so we have, make sure you double check these. Milligram on top here, gram on top here. So we have the weights on top, but the units are different. So we change this to 1,000 because 1,000 milligrams equals 1 gram. Okay, so now we have our units the same. So 1,000 times 1 would be 1,000. 200 times x goes on the bottom. Okay, you can take out your zeros if you want to make it easier calculations in the thing. 2 zeros on top, 2 zeros on bottom. So 10, of course, divided by 2 would equal 5. Okay, so our total is 5 milliliters. We're going to subtract from that 4.2 because this is our total. So this is your total, or also known as your final volume. So your 5 minus 4.2 equals 0.8 powder volume, and PV's powder volume. So you would add 4.2 water, of course, to that 0.8 powder, because remember the bottles come in a powder form, so that powder is what's going to be in there. And you add the water, which is 4.2, and your becomes your total. Okay, that's 5. But your answer, because they're asking for what's the powder volume, it'd be 0.8 milliliters. Okay, next we're going to do number 4, and I'm not going to write it out here on the board. But you have a vial of penicillin G potassium containing 20 million units. The directions are to add, so I'm just going to make some notes up here. We're going to add 32 store water for injection. We know we have 20 million units. Okay. The directions are to add, we put 32 milliliters, and it's SWFI stands for sterile water for injection. So we're going to add 32 milliliters of stored water for injection to reconstitute to a concentration of 500,000 units per milliliter is what we have in stock. Okay. What is the powder volume of the penicillin? So I just jotted that down so I know. We're going to save this for last. We're going to take our 500,000 is what we have in stock per 1 milliliter. You have, want to take it out, 20 million units. So the vial contains 20 million units. So then we're going to have X milliliters because we want to get our total. Okay. So we have units both on top. And you have milliliters on bottom. So 20 million times 1 is going to be 20 million. X times 500,000 is going to go on the bottom. Again, you can mark out your zeros. We have 5 down here. Mark out 5 on top. 1, 2, 3, 4, 5. Okay, and then we're left with 200 divided by 5, which makes it a little bit easier than putting all those zeros in the calculator. And you should come up with 40. So your total, or your final volume, is 40 milliliters. Okay. So then we know we're going to add 32 to it. So we want the powder volume, so we're going to subtract that. So subtract your 32 for your water. I'll just put W for water. And your answer would be 8 milliliters of your powder volume. Number 5, again, I'm just going to kind of jot up here. You have the directions for a vial containing 500 milligrams of powdered rocephin. State that the addition, so we're going to add 1.8 milliliters of sterile water for injection. Will yield a solution containing 250 milligrams. I'm going to go ahead and put it up per 1 milliliter because we know that's what we have. Okay. What is the powder volume of the drug? Okay. So we know we have the 500 milligram of the powdered Rocephin. Okay, we're trying to find the powder volume. Powder volumes will be X milliliters. Okay. So we have milligrams and milligrams, so we're good. Milliliters, milliliters. Okay. Cross multiply. 500 times 1 goes on top. 250 times X goes on the bottom. Anytime you multiply by the X, it always goes on the bottom. 500 divided by 250 is going to become 2. So 2 milliliters, and this is of your final volume. It tells us that we're going to add 1.8 milliliters stir water for injection. So then we're going to subtract that from the total to get the powder volume. So 2 minus 1.8 equals 0.2 milliliters of your powdered volume. Okay, now we have some that are a little bit different. So these, because what it is asking, what will the concentration of the drug be after reconstitution? Okay, so we're going to do this one a little bit different. We're not doing the ratio proportion on this one. So you have whatever you're going to figure up your final volume first. So you have your water, okay, let me just do it this way. Sorry. So it'll be your sterile water for injection. Then you're going to add your powder volume, and that's going to equal your final volume. Okay, and then you're just going to divide. So number 8, if you add 27 milliliters of diluent would be your store water for injection, because remember most time it's that. So that would be your 27 to a vial containing 2.5 grams of drug that has a powder volume of 3. So your powder volume is right here, so 3. Okay. What will be the concentration of the drug after reconstitution? So then we got to find, first we got to find our final volume. So 27 plus 3 will be 30 milliliters of your final volume. And then you have your, it tells you in the question that the vial contains 2.5 grams of drug that has a powder volume. Okay, so what will the concentration of the drug be after reconstitution? So you do have to, it has to be in milligrams per milliliters. Okay, that's just something that you have to remember. So you have to convert your 2.5 grams. You're going to divide that, the first 2.5 grams divided by your final volume. Okay, so 2.5 grams, you're going to convert to milligrams. So that would be 2,500. So you just multiply it by 1,000. Okay. So it's 2,500 divided by 30, and you have 83.3333. Okay, so that would be milligrams per milliliter. So you have 83.3 milligrams is the concentration of the drug after you've added, after the reconstitution, after you've added the diluent. And once you go through these practice problems, it'll do a couple like this, and it'll do a couple like the ones we did before, and it goes back and forth, so just be aware of that. Okay, number 11 is like the one we just did. You have 10 milliliters of sterile water for injection. It's to be added to a 1 milligram vial of methoxin, given a 10.5 milliliter final volume. What is the concentration of the reconstituted powder? So our sterile water for injection plus our powder volume, remember, it's going to equal our final volume. Okay, so it tells you your sterile water for injection, of course, is 10 milliliters. Okay, and this one It doesn't tell you, of course, your powder volume, so we're going to put that as X. But it tells us our final volume is already 10.5. Okay, so we actually don't have to do any additions here because what we need is this final volume number anyway. So I just want to kind of write that up like that just so you know you don't even have to worry about adding or anything because it automatically just told us that the final volume is 10.5 milliliters. Okay, so what is the concentration of the reconstituted powder? So we know that the 10 milliliters of water is going to be added to 1 gram of medicine. Okay, so you have a 1 gram and you divide it by your 10.5. So this formula pretty much, if you like to have it written up for you, is going to be, of course, the drug divided by your final volume. Okay, and just remember your drug has to be in milligrams, and this has to be in milliliters. Okay, so 1 gram, when you convert to milligrams, you just times it by 1,000. So 1,000 divided by 10.5 equals 95.2 milligrams per milliliter. So the concentration of the powdered methoxin, of course, is 95.2 milligrams per milliliter. Number 12, again, sterile water for injection plus your powder volume is going to equal your final volume. Okay. So if you read this, you have 6 grams of the drug, and you know it's going to be your drug over your final volume, if you like to put it up like that. Okay. So as we're reading, if you wanted to plug in the numbers, you could do that. But okay, we have 6 grams, of course, of your bulk package for Fortes. That's the drug. So it's 6 grams. And I'm just moving it over here. It is reconstituted with 26 milliliters of your sterile water for injection. What will be the final concentration of the drug if the powder volume is 4 milliliters? So your powder volume will be 4 milliliters. Add those two together, you get 30 milliliters. And so your final volume is 30 milliliters. And remember, this has to be milligrams. So 6 times 1,000, because there's a 1 gram equals 1,000 milligrams. So that would be 6,000 milligrams. Again, you could take the 0 off, and make it easier to put into your calculator. 600 divided by 3, or you could say 6,000 divided by 30 would equal 200 milligrams per milliliter. And that would be your final concentration of the drug. Number 13, I'll do one more. So again, sterile water for injection, powder volume, plus that equals your final volume. And then you're going to have your drug is going to be divided by your final volume in order to get the total concentration. So if you do your read your problem, you add 23 milliliters of sterile water for injection, water into a 3 gram vial of antibiotic, so your drug is 3 grams. It has a powder volume of 3 milliliters. Add those two together, and it makes 26 milliliters. Final volume, okay, you have 26 milliliters. What is the concentration in milligrams per milliliter of the reconstituted drug? So again, we have 3 grams. Going to change it to milligrams. So all we do is multiply it by 1,000. So that would be 3,000 milligrams divided by 26, and you should come up with 115.4 milligrams per milliliters. Okay, if you have any questions, just send me an email.